Welcome back to Educator.com. This lesson is on the periodic table of the elements. The periodic table of the elements organizes all the different elements, which are different types of atoms. It organizes them by their increasing atomic number. Remember, the atomic number tells us the number of protons that there are. So, as you add protons, you go to the right on the periodic table. We'll take a look at one a little bit later and you'll see what I'm talking about. Each square on the periodic table represents one different type of atom or one element. So they'll look like this. They will have a number here, which in this case is a little 5. That number is our atomic number. Okay, and then there'll be a symbol, and that's something that represents the abbreviation for the element's name. This symbol right here is a B, so we call that our chemical symbol. That one's for boron. A chemical symbol is the abbreviation, and it's one capital letter, and it could be one capital letter and one lowercase letter to differentiate between the elements. And we'll talk about these more and more. You'll get familiar with, like the first 20 we'll be pretty familiar with by the end here. But for now, boron represented by a capital B. Then there's beryllium, and that's also starts with a B, so they have to make beryllium a B with a lowercase e, so that you know it's beryllium instead of boron. Okay, so we'll take, like I said, we'll take a look at those later. And then the other important part of the periodic table is this little number right here. That little number is your atomic mass. Okay, so it really tells you the mass of your atom. Now, the funny thing about atomic mass, or the complex thing I should say, it's not really that funny, it's complicated. The atomic mass is not the mass of every boron atom. They don't really all weigh 10.81 and then AMU, atomic mass units. They don't really all weigh that. What that is, it's the weighted average mass of the isotopes of that atom. So we looked at isotopes before. As a reminder, those are the same atom, so it has the same number of protons, but the number of neutrons can change. So we have boron, B11 and B10. Remember that 10 and 11, those are the mass numbers. Those are the protons plus the neutrons. So 4/5 of all boron exists as B11. So that's boron with 5 protons, because the atomic number is 5, and 6 neutrons. 1/5 of all boron exists as B10. So that's boron with 5 protons and 5 neutrons. So what we want to find when we're finding our atomic mass, we're looking at the weighted average mass. Weighted means it depends on the percentage of the time that what they exist as. So if it exists as B11 4/5 of the time, you do 4/5 times that mass number, 11. And then you add that to your 1/5 of boron 10. Okay? And when you add those together, that's finding the weighted average mass, you're going to end up with your 10.81. Your 10.81 AMU, that's much closer to the B11, the mass number of B11, than it is to the mass number of B10, which makes sense since boron usually exists as B11 with a mass number of 11. Only 1/5 of the time does it exist as a B10, so the number should be closer to 11 than it should be to 10. And so that's what the atomic mass is. That's why they're all percentages, since they're average atomic masses.